All right, I am starting at the end with how to use your calculator. For number 41, you have 10 to the power of. To undo 10 to the power, you log base 10 both sides. But base 10 logarithm doesn't need to be written. So what I'm trying to do is just show I am taking log base 10 of both sides. That causes the log base 10 and the 10 to the power to cancel each other out, just like adding 5 and subtracting 5 would cancel each other out. And that leaves me with x being log base 10 of 15. So with that, you need to know if your calculator needs to have the 15 typed in before you push the log button, or if you push the log button and then 15. So everyone try that out. Get your calculator. You're doing this. And also the directions are to include 3 digits after the decimal point. So make sure you give 3 digits after the decimal point. And for this problem, when you put that in your calculator, you are getting 1.176. If you are not getting that, make sure that you ask for help before the quiz today. For number 42, it's another problem very similar to this, except it has an extra step. So just like before, you log base 10 both sides. And just like before, the log and the base 10 cancel each other out. So now you have x plus 4 equals the log of 200. So after you find the log of 200, you'll subtract 4. And you should be getting, let me make sure my parentheses are in the right place, negative 1.699. Make sure you are getting that. Okay, moving on to now, let's do number 43. Now, if your calculator does not allow you to put the base of the logarithm in it, you're going to need to use a base 10 logarithm. But you have to first isolate the exponential before you can undo the exponential. So you're going to add 7 to both sides. And now it's ready for you to log both sides. If you have the ability to put your base in, just log base 3 both sides and solve it basically the same way as 41 and 42. But if you don't, then you are going to log base 10 both sides. That does not give you that cancellation. But what you can do is use the log rule that the exponent can come around and multiply in front outside that logarithm. So you have x plus 5 in a parentheses. Make sure you've got a parentheses around it. And then you can divide. So x plus 5 equals log of 45 divided by log of 3. And then basically do the division of the two logarithms and then subtract 5. Everyone make sure you practice with your calculator that you're able to get the right number. And you should be getting negative 1.535. Yes, this is the practice test. And I'm just going to go through the whole practice test. I've found that that typically works best for most people. Okay, I am going to erase this work so that we can see a little bit better. All right, the next problem. Make sure you isolate the exponential before you undo it. So subtract 8, that's going to give you 148. And practice with your calculator. Make sure that you know how to use the base if you have the ability to use a base that isn't 10. And at this point, you log both sides. Use base 1/3 if you have that ability with your calculator. And because that 1/3 doesn't match the base, you can't cancel them, but you can take that exponent and move it to multiply in front. And then you have, with the parentheses around the 2x minus 3, log of 1/3 equals log of 148. Then make sure you divide by the log of 1/3. And then you will do add 3, divide by 2. So make sure that you can do that with your calculator. Everyone practice using your calculator. And you should be getting negative 0.774. If you did well on the quiz, you don't have to take it again. If you didn't get a perfect score, I would recommend taking it again. Finally, for 45, that one has a bit to make sure that you do before what I just circled is isolated. If you just kind of circle that exponential piece, it helps your eyes to focus a little bit better on the fact that you're going to subtract 12 and then divide by that negative 2. So subtracting 12 is adding 12 and then divide by negative 2. And that's actually 81. So now, if you have the ability to do log base 5, do log base 5. But if not, then you've got to go the longer route, log base 10 both sides. And that can multiply in front. For 44, I got that by, let me actually make sure that I didn't mess that up. So you've got the division of the two logarithms. It'll be different questions, but essentially the same thing. The log of 1/3 actually comes out as a negative number. In fact, if you put into a logarithm any number between 0 and 1, you'll get a negative number. And so then that division creates the negative. Then add 3, divide by 2. And yes, at the end of class, you'll be doing the quiz retake. So then that is everything from that last bit, which again, that's what's on the quiz today. And it will be similar to Friday's quiz, but it'll be different numbers. So you've got to use your calculator. By the way, do any of you have the graphing calculators, the TI-84? Okay, because those, while it's not obvious, they do have the ability to put a base in for the logarithm. So I just wanted, if anyone is listening and you don't want to speak up, that you need to know how to do that. If you go to the catalog button is basically right above the 0. If you go to catalog and push L and then scroll, you'll find where it says log base, where you can put the base in. All right. Then I'm going to kind of go backward and just slowly head back up to the beginning. It's really important with solving equations that you recognize when you have a condensed logarithm and when you do not have a condensed logarithm. So this would be valuable. Everybody, just look at the screen. And I want you to decide which of these logarithms are condensed and which of them are not condensed, and you need to do something to condense them first. Let's start with 31. Is 31 condensed? Is it ready to undo the log? Yes. Number 32, is number 32 condensed, ready to undo the log? No. Very good. So with 32, we need to deal with the addition of the logarithms. And if you're adding two logarithms, how do they condense together? Correct. Multiply. And you can decide if you want to multiply the binomials together now or later. But take a good look at 32 now, and do you see that it is now condensed? There's nothing outside either of the logarithms. You can undo them. They basically undo each other. You can see it as 2 to the power in both sides, or that they just, same operation on both sides. Then we need to multiply that binomial out. And if you need to do box multiplication, do box multiplication to not mess it up. And then when you're solving your quadratic, make sure you get one side equal to 0. And then factor. And I'm looking for two numbers that multiply to make -10. And when I add them, I get -3. Factor whatever way you know how to factor. And I get 2 answers. But with the logarithms, do you remember that you have to check? I don't need to see that you're checking, but if it doesn't work, I need you to cross it off the list. And the check is, you go to the original problem and look at each of the insides of the original logarithms. In order for x to be a solution, it has to create only positive numbers to go into the logarithm. So I need 5 to make x minus 3 positive. 5 minus 3 is positive, it's good. 5 plus 1 is positive, 5 plus 7 is positive. 5 is an answer. With -2, just x minus 3. -2 minus 3 is a negative number. It is an extraneous solution. And it comes about because logarithms have a limited domain. And when you undid them, you made a function that had a limited domain turn into a function with unlimited domain. And really, we're just checking to make sure that the answers are within the domain of the original logarithms. So x equals 5 is the only answer. And if you see what I did there, just crossing the number out and then re-expressing this as my answer is a really good way to show me that you checked and came up with extraneous. Let me go back over to 31. 31's ready to go, but it's not a log equals a log. It's a logarithm equals a number. So you need to undo the logarithm with its inverse, 5 to the power of. Then 5 to the power of log base 5 are opposite operations. They undo each other, and x minus 1 is left. And then 5 to the power of 2, 25, and then add 1. And it's a quick check. Is 21 or is 26 minus 1 positive? Yes. Good. Answer. Done. Now, everybody look at 33. Is 33 condensed and ready to go? It is not. That 1/2 that is multiplied outside, everything needs to come inside a logarithm on each side of the equation. That goes into the logarithm by making it an exponent. And if you recognize that the 1/2 power is the same thing as square root, you can change that to square root. You do not have to. At this point, are we now ready to undo the logs? Good. So those undo each other, and you have x to the 1/2 power equals 5. You might see it better if you write it as the square root of x. And then take a moment to think about the opposite operation, because I've seen a lot of people make silly errors because they're just going too quick. Take the time to recognize you need to undo the square root by squaring both sides. And then double check, does it make a positive going into the logarithm? And yes, that problem is done. I'm going to erase number 32. I do have the answers available online, so you can look at that, but I'm going to erase these so I can see better, so I can show you better. Number 34. Is that a condensed logarithm? Am I ready to just undo the logarithm right now? And I'm checking chat. For 34, am I ready to undo the logarithm, or do I need to condense? So actually, I think I asked both questions. So yes, I'm not sure what that refers to. What do the rest of you think? Is this, am I able to undo the logarithm right now? I'll make that the question. Correct. And the problem is this addition. So just look at what you have, take the time to read it, think about what's inside, what isn't inside, and how to make it you're missing some letters there, and I'm not entirely sure what you're saying. Yeah, okay, yeah. So if I'm adding and I condense, if I'm adding outside the logarithm, that condenses to multiplication inside the logarithm, the exact opposite of that exponent rule. And then take a look, do you see that we are ready to undo the logarithm? And you can just see, hey, they undo each other. Or you can 2 to the power both sides. Then this, I already did 32. Okay, we were on 34, and then you said yes, and that was correct, but it was because of the subtraction, and now I see what you were saying. Gotta make it to fractiona and add. The subtraction turns this into division. And then that's an understood base 10. When it's not written, it's understood to be base 10. So if I 10 to the power, that will undo the log. Then I have the fraction inside the logarithm being equal to 10 to the power of 1, so it equals 10. Now, you've got to remember this tomorrow, because I tend to always find someone gets a little bit lost right here. When you see a denominator, you want to multiply both sides of the equation by that denominator. Know that that is your key to getting out. So I'm multiplying both sides by x minus 1. And now I'm going to subtract 6x over to the right, and I'm going to add 10 over to the left, and I get 11/4. I need to check and make sure that it makes the original logarithms positive numbers. And just taking a moment to think about it, I can see it's all good to go. So that is the answer. Okay, I'm going to erase 33. And this time I'm going to scroll my screen up so I don't accidentally think that I'm in the middle of a previous problem. So don't expect the problems to just be starting with the easiest and getting harder and harder. I've got it kind of mixed up. This one, completely condensed, ready to go, 10 to the power both sides. And that gives you 10 to the 4th power, means 4 zeros after the 1. And that does make a positive number go in the logarithm. I'm going to erase the bottom of a previous problem. And for 36, you have a condensed logarithm. It's a base 2, 2 to the power both sides. And x is now equal to 2 to the power of 6, which is equal to 64. And quick double check, it does make a positive number go in the logarithm. Okay, 37 and 38. Do either of them need condensing before undoing the log? Right, 38 needs condensing. Now, listen, I highly recommend that tonight you look at a blank form of this practice test and see if you can do all of these problems on your own without someone helping you through and without looking at the answers. Check the answers, but do this until you don't have to check the answers. All right, so 37 is ready to go. 3 to the power both sides, and 3 to the power of -2, it is 1 over 3 to the positive 2, 1/9. And it does make positive in the logarithm. 38, we've got to condense. And I will only give you logarithms with the same base within an equation. And when I multiply the insides, I have condensed the logarithm and I'm ready to undo. I can either realize that they're the same log, they undo each other, and I'm going to have to move down here. Multiply your binomial, take the time to do it right. That could mean that you do box multiplication. Then make sure you set one side equal to 0. And ooh, look at that. And then subtracting 1 gives me -16. And since we lost our x term, you can add the 16 over and do the plus or minus square root, or you can factor to get x minus 4, x plus 4, whichever you see. That gives me 2 numbers, and then I'm going to check. Do both of them make x minus 3 positive? And you see, do both of them make x minus 3 positive? Correct. -4 is out. Now I only need to check 4. 7 times 4 is 7 times 4 is looking for chat. 28. Okay. It makes a positive, and then 4 plus 1 is positive, so x equals 4 is the only answer. Okay, here's what I'm going to do. How about I come back to 39 and 40 after doing some other problems? Let's kind of shake off the logarithms a little bit. You do you. Okay. I'm requiring 3 accurate points be plotted. You need to know how to graph x cubed and the cube root of x along with the logarithms. And you can always figure it out by making a table. Plug numbers into x. You should know that it goes through 0, 0, 1, 1, -1, -1. You should know that it is flat in the middle, and then it is very steep. In fact, if you plot the point 2, 8, you'll get the idea of how steep it is, as well as -2, -8. Doesn't have to look perfect, but I need to see the idea of this shape in your drawing. If that means you erase and try again, do that. And I'll come back to the domain and everything. If I multiply by a negative number, I take all the y values and multiply them by negative, and that will cause it to flip upside down. It'll still go through the origin, but now it's 1, -1, and -1, 1. And it still keeps that basic shape. I'm not requiring you to plot the points 2, -2 with 8, -8, but know that it'll help you a lot. to plot those. And now finally, we have the negative x cubed, like we have in B, but the x has a 2 subtracted, and the function has a 4 added. That means we're going to take the points that we see, these 3 points, and we are going to move them right 2 and up 4. And remember, x always does the opposite operation. So it may help to plot them and then just move them right 2 up 4, and boom, right 2 up 4, and right 2 up 4, and draw. And when you're using the graphing program in the Go Formative, it's really nice to use those little circles to plot points. I can see very clearly that you know where the points are if you plot those points. If you don't plot them and your graph isn't in the right spot, I'm going to have to mark you down. So plot those points, show it clearly. And does everyone know that for these graphs, domain and range all the way through negative to positive infinity, every one of those answers? The inflection point is at the origin before movement, and then after movement, we moved it to the point +2, +4. For the cube root graph, remember that's the inverse. It contains the same points. In fact, let me zoom it in a little. It goes through 0, 0, 1, 1, -1, -1, just like x cubed. But instead of being flat in the middle, it's steep in the middle and turns sideways. And, do your best with drawing. But do you see the difference in how this one is more vertical? This one is more horizontal. Make sure that you show that behavior. If I multiply outside a function, I take the y values and I multiply them by that exact number. So this y value of 1 and this y value of -1 are going to be multiplied by 3. So that means that I will have same x coordinate 1, but instead of 1 for the y will be 3. And then this point will keep the -1x, but be -3. And 0 multiplies to stay 0. And then just make sure that it has the idea of the shape. And then lastly, notice that this is still 3 times cube root of x, which is where we left off, plus 2 with the x minus 1 outside the function means that we are going to move left 2 and down 1. Opposite direction for x, same direction for y. And I'm going to plot the 3 important points that I'm following from the previous graph and then move each of them. So I'm going to move each of them left 2, down 1, left 2, down 1. left 2, down 1. And then just draw it again. Just like x cubed, domain and range, all across the board, negative infinity to positive infinity. And just like x cubed, the inflection point is at the origin. It's just when it's x cubed, it's a flat inflection point. When it's cube root, it's more of a vertically sloped inflection point. Multiplication will not change what happens at the origin, but movement will. So we went left 2 and down 1. And if you just see what the motion is, that tells you where the point that was at the origin has moved to. All right. Who's falling asleep? Okay. Shake it up. Wake yourself up. And I'm assuming this is helping you guys, though, to look at all this and remember everything about the logarithms. To keep things kind of moving around a bit and not get stuck in the same idea over and over again, I will skip around a bit. So let's look at expand condense for a little while. You can do this one small step at a time or one big giant step at a time. When you have division inside a logarithm, it will split the logarithm into 2. And what operation will I have? Good. Subtraction. Then, as I look at this first logarithm, I see that I have multiplication of 3 different things. Then I'm going to write this as 3 separate logarithms, and what operation do I have between them? If they're multiplying inside, they will, looking in chat, add outside. Good. And then if you look at what's inside the logarithm on the minus, it is not multiplying to anything, but it does have an exponent. But I'm just going to deal with the exponents in one step. All 3 of those, their exponents can come and multiply in front. And do you recognize, or can I simplify log base 4 of 6? Okay. Do slash marks mean something? Okay. Because I see dittos, so I don't know. Okay. Anyway, okay. Oh, it happens. On the test, I'm not going to throw at you things where you can simplify with the number in this situation. I feel like it's a bit much to, while you're expanding, have to worry about checking to see if you can go a step further. Is 64 4 to a power of something? Sixty-four is 4 to what power? There you go, 3. And then I'm going to bring those exponents and put them in front, and that will be it. Oops, I'm writing the wrong number. 22 is a beast, and it's a nice challenge on a practice test, but I would not give you that much of a beast on a test. I'm going to focus on 21 and then move to another problem. You want to remember that a square root is the same exact thing as a 1/2 exponent. And with logarithms, that means you can bring that to multiply in front. And make sure you're clear that you cannot break up addition subtraction inside a logarithm. It's awkward. You feel like you should be able to do something, but you have to leave it. And this is the most you can do to expand. Okay, let's look at condense. When you're condensing, what multiplies needs to be the first thing. And, condensing is the reverse process of expanding. So what we did last, we will now do first. We will bring these multipliers inside the logarithm as an exponent. Now, be careful. You have two subtraction signs. You either need to realize that that means they both end up in the denominator. Let me just do that. I'll write that out. Or as you look at it, you may need to see that you can factor a negative and when they are adding together, you multiply what is inside and then it'll end up being in the denominator. So I'm hoping that that makes sense. And Chris, that's becoming distracting. All right. I'm going to roll around a little bit again. And I did have these two swapped between, okay. Okay, thank you. So I do have these two switched on your practice test on the answer key. I have them this direction, but it doesn't matter that much. I do want you to be able to look at these logarithms and know what number they are. And what you're asking yourself is, what is the exponent on that base that will give you what's inside the logarithm? Negative exponents create denominators, and 4 squared is 16, so this is -2. For number 2, you've got to remember that that is a base 10 logarithm, and basically count the zeros. 10,000 is 10 to the power of 4. 125 is 5 to the power of 3. Good. If a 1 goes inside a logarithm, what comes out? No matter what base. Good. 0. For number 6, which was your 8, 49 is equal to 7 squared. For number 7, 64 is 2 to the power of, and that one's a little bit harder because you have to multiply so many times. I wouldn't have put that problem on the test. For number 8, you have a fraction 36 is 6 squared. Negative creates the fraction with an exponent. And then last, number 5, if you have the reciprocal of your base, then the exponent is -1 to make that reciprocal. All right, now, did you enjoy this batch here of problems? Did you enjoy that batch? I knew you probably wouldn't enjoy it. Yeah, I know. But I wanted you to make sure that you've got a feel for what logarithms are. Yeah. And I appreciate that you did these problems, and it helps you to be able to do these first 10 problems more easily. It helps you to understand logarithms better. Yeah, I can go over one of the quiz problems from Friday. I have decided that I'm going to cut that out of the test. I'm not going to put that on the test. It is on the practice test, so you do have to turn that in. The work has to be done. But time-wise, I'm going to cut that out of the test. Oh my goodness, the test is tomorrow. The test is tomorrow. That's why I'm recording this session too. That is very true. A lot of math actually turns into a puzzle. So know that I will give you a few problems like numbers 1 through 10. I'm not going to give you anything from 11 through 19, but I will have you doing like one expand, one condense, and the graphing of the logs. That I did not spend any time on yet. All right. Every single log graph, no matter what the base, what is the one point they share in common? They share that x-intercept. Good. If the base is a number that is greater than 1, then it heads down the asymptote. To get a second point, look at the base of the logarithm and think, if I plugged the base number in, if I plugged 5 in, the answer would be 5 to what power equals 5? You would get 1 out. And that's enough to draw a graph. For part B, we are taking that graph and we are moving right 2 and up 1. So I'm going to plot these points that I have, and I recommend that you do that as well. And in fact, when you have to move a graph, you may want to draw in a little asymptote of where it was and move that asymptote. If I move that asymptote right 2, moving it up 1 isn't going to matter, but right 2 helps me to find where that asymptote goes. You don't have to draw the asymptote if you show the graph heading toward that, but this may help you. Now I'm going to take the point that was 1, 0, move it right 2, up 1. I'm going to take the point that was 5, 1, move it right 2, up 1. I'm going to overemphasize those 2 points. Again, you don't have to draw that asymptote, but you do have to show an asymptoting of the graph. The domain Logarithms only get positive numbers in their domain. And when I move it horizontally, that moves the domain, but the range is everything. Now, important, notice it says equation of asymptote. Don't write just a number, you need to write the equation. Vertical lines have equation x equals. And the asymptote is first at 0. When we move it, it is over to x equals 2. Then I have a base 10 logarithm. I'm going to draw that one real quick. I've got the one point that all of them share. And if I find the x coordinate that is the base, its y value must be 1. And it's asymptoting. Yeah. Which is really hard to draw. And we have 5 minutes left. Remember that the multiplication by negative flips it horizontally over the y-axis, which causes these 2 points to move here. And then I threw in 2 things all together. So it flips and then it moves up 2 units. Now I'll go ahead and tell you that I am not going to give you a base between 0 and 1 for your logarithms. I want you to be very familiar with the logarithm with a base greater than 1. That's the one that typically is used. Yeah. Let me see. What did I do? Okay, yeah, somehow I really messed that up, didn't I? Good job. Well, you you can see where my breakdown of focus hit. Okay, I will need to fix those 2 and upload them right after class. So it was these 2, correct? The B's? Yeah. Yeah, sometimes brain do a melt. Okay. Excellent. Thank you so much. I need to get the test started. I'm going to stop the presenting, but